So let's start area and we'll see, we'll try to revise where we were last time, right? So we were able to make the ball come down under the gravity, but the ball keeps bouncing
forever.
So now we'll try to see how can we make the ball slow down, right? Yeah. So one of the things we want to talk about is we have something called as acceleration, right? Okay, but this was basically the gravity, right?
Yeah.
So let's just call this as gravity,
and then
the acceleration
now
is,
changes to gravity.
yeah, we will just say acceleration is initially 0, right? So vec to v and it's gonna be equal to 0, 0, right? So the acceleration is 0, 0, right? So if we run it, every frame the acceleration is the same, 0, so the ball goes forever in the same path.
Yeah, path.
Right, same path. Now how do we slow down things, you know?
We need some friction in the air.
So one of the way we can do is we can make the acceleration, we can have something called something called as drag.
Oh, drag is maybe friction in the air.
So drag is basically friction in the air. So what the acceleration will look like? The acceleration is gonna be 0 plus drag. 0 plus drag. So how do we calculate drag?
Well, I don't know.
So drag is basically something which slows the velocity. So it has to be something which is in the negative direction of the velocity. So minus velocity into some scaling factor. Minus velocity into some scaling factor means, like, do you want it to reduce by half? Do you want to reduce by quarter? Do you want to reduce by 1 by 10? So there has to be some
0.8.
Yeah, 0.8 is a lot. So that will slow down very quickly. Okay.
0.5.
So let's say we want to find the minus velocity, right? First of all, so we want to find the minus velocity. So we'll use the previous, what is the velocity previous frame, and then we multiply it with minus. We can do 0.1.
What?
0.1. Okay. So remember, we want to do first write velocity first, and then we want to write the factor. We do the other way around, it will not work because this is how this one is. Okay. So now if we run, and then we don't have to do 0 plus drag because that is equal same as drag. So now if we do this, then our acceleration is just drag.
Yeah.
Our acceleration is just drag. So what happens? It is still going too fast, right? So maybe we'll just change the velocity a little bit. We'll make it 200, so that it goes
little x more.
Yeah, x more little bit, and it go too fast still, right? So maybe 400. No, well, maybe let's slow it down. So this was 200, maybe 100, and make this as
50.
Maybe 50. Okay, so let's try this. Now what happens? It is going
Slow. Oh, it's gonna stop.
It's going very, very slow now. It is going so slow that is probably gonna go stop. Will it stop?
Well,
so yeah, maybe let's increase the drag a little bit more. Maybe let's increase the drag a little bit more, right? So let's see what happens. So you see how the drag is there, so the thing stopped, right?
Yeah.
So if you live in a world where there is no gravity but there is some air there,
yeah,
that's what will happen, right? That you will throw something, it will go fast but eventually stop in the air and it will stay forever.
But outer space have none of them.
So outer space has none of that. So that's why the thing will keep going forever. So if there is air, the air will work as a drag. It will stop you.
It's basically
friction in the air.
Yeah,
air. So it stopped, right?
Wait, why is it not falling on the floor?
Because there is no gravity.
Oh.
So when the gravity and drag is there, then it goes like this. So both the thing will combine. So how do we combine both the things? To combine both the thing, we need to add the gravity to it, right? We need to add the gravity. Now every frame will calculate the gravity as well as the so the acceleration now is the drag as well as the gravity. So both combine, will combine both of them now. So now you can see it just fall down and like this it just, yeah.
But we didn't throw the ball fast enough.
Yeah, maybe the drag is just a little too high. We just want to make the grab 1 and we'll want to throw the ball a little higher, I guess. Maybe we'll just see. Oh yeah, we want to throw the ball a little faster, right? So maybe make it 200 and 100. Okay.
150.
So let's try this. So we tried to move the ball a little higher, and then yeah, now it is working fine.
What does it balance?
Yeah, but the bigger issue, remember, was that it was bouncing. Let me just see. So it's bouncing slowly.
Oh, it's gonna stop. Yeah, but Earth doesn't bounce so much.
Yeah. So there's another thing, there is another thing called the drag is stopping things in the air, right?
Yeah.
But there is another thing. See, now what is happening? It is moving, right? It is moving, right?
Yeah, but it's sinking.
Why this is happening? Why this is happening? Yeah, this thing is happening. Why does this thing is not stopping? Why this thing is happening? So this is what we need to kind of understand. This is another problem which we need to understand. So this is the trickier one. So remember, what's happening is that we have this surface, right? Now the ball could be here, right? The ball could be here, right? So if the ball is here, what will happen in this frame? So this is the first frame.
Yeah.
So our code says
that it should bounce because it's like.
Yeah. So it should say that it could bounce the other side. We reverse the we reverse the direction of the velocity. Right?
Yeah.
We reverse the direction of the velocity.
Because this is underneath.
Yeah. But there is another thing we do every time we are here. So suppose this velocity was, let's say, what is the downward velocity? The downward velocity is? Let's say what is the downward velocity?
Positive.
So the downward velocity is this.
Positive.
Huh?
It's positive. 150 positive.
This is the x, no? This is the y, no? This is minus, right? We are going up. But it could be positive, right? But if the ball is going down, it could be positive. So it should be positive.
Like, so that is positive direction.
Yeah.
If
So this velocity would be something x and then something like maybe 100 or let's say maybe 10, whatever, right? So some positive, right? Right? Downward. And it's totally possible that we'll add acceleration to it. So this will become x comma 20 or whatever it is acceleration. Let's look at what is the acceleration. The acceleration is 100.
Yeah.
100. So it's a lot, right? 100. So we are here and then we'll add 100 to it. So it will become
200.
Yeah, 200, something like that. So you see the problem, right? So and then we'll reverse this and then we'll reverse this. So it become minus 200. So that is the reason it keeps bouncing forever. So you see what is happening. So we are adding this gravity when we are close to the wall.
Yeah.
It's not such a good idea, right? We don't want that to happen.
Yeah.
Okay.
No. Right? Why does it add gravity only when it's close to the wall?
So it always add gravity, remember? So
the
thing is that when the ball is here, when we go this direction, that means the velocity was this is positive, let's say 100 and then minus 100, right? Right? And then what we do is our acceleration is 100 and downwards, right? 0. This is our acceleration, right?
Yeah.
But we will add only a small portion of it to the next frame. Why? Because it will apply in 1 second. So there is only a small second. Let's say this is the next frame. 10 millisecond has gone, right? Right, or 100 millisecond, let's say, have gone. So we'll add only 10% of it, right?
Yeah.
So 10% of will be 10, right? So this will become, the ball will change, the next frame the velocity will be 190 minus 90, and the next frame it will become 100 and minus 80, right?
Yeah.
So the velocity is changing because every time we are applying the gravity, and gravity is only changing the y component. It is making it more and more positive, more and more positive. But once you reach near the ground, remember,
Yeah.
once you reach near the ground, you will have some positive velocity, right? Right, some positive velocity, maybe let's say 100. Let's say 100 positive velocity, okay? Because it was going minus and then it will become positive, right?
Yeah.
So it becomes something positive, right? Now what it will do, if you hit this surface, what we did, we said that we change the velocity to minus, so it will become automatically, the same thing become minus 100. The same thing become minus 100. So it will go up till there again. Slowly it become less and less negative, and then again it will become more and more negative.
Yeah.
So the velocity keep going first. You know,
and
initially
it never stops.
it never stops. It never stops.
Yeah.
So the only way we can make it stop is by adding the drag component.
Yeah.
So drag is basically slowing down both the x and y velocity component, right?
Yeah.
But that's okay. Ignore the drag part. But what is the bigger issue? What is coming here right now is when we are close here, right? And if I am here, I want it to eventually for the ball to stop here. We don't want any gravity to apply to it, right?
Yeah.
So the problem is that because the gravity is applying, it is kind of moving up and down. Okay. So that is the reason. So if you are here and if there is no gravity, then the ball will stop.
Okay.
Because so that's what is happening. So suppose the ball was here, you apply the gravity, it increases the velocity in the downward direction. But then because it is a small component, so it moves a little bit, right? But because it's near here, then it will move in the other direction also a little bit. But then gravity will pull it back.
Yeah.
So that's why it's kind of bouncing back and forth. Okay. So you can understand and try it out. You know. So did you understand properly?
Huh?
Did you understand it? Not well, really well.
Yeah.
Not really well. Yeah. So let's try to see. Maybe give us a good example for this problem. That's why I was saying, right? You need to kind of understand this. Okay. So let's say you are here. Okay. You are here, and let's say your velocity. Let's say you start, your velocity is 0, 0 now. Let's say. Okay. And let's say your acceleration or the gravity is 0, 100. Okay. And let's say this is the next frame. So what happened in the next frame? You will apply, and this was your velocity. So you are stopped. Let's say you are stopped. Okay.
Yeah.
This was your velocity. Position doesn't matter. We just talk about the velocity. Now what you'll do? You'll apply the gravity. So what will happen when you apply the gravity? The velocity becomes not 100. Let's say there is only between these two frames there is 10 or 100 millisecond passed. Okay. So now you'll add 10. So it will become 0,
100.
10.
10. Oh yeah.
10, not 100 because it's only 10 because it's 1 second, then it will be 100. It's only 10 milliseconds. So now this was applied.
Yeah.
So you will move the ball little bit down. Let's say, right? So what happens because of that? You touch you. Let's say you are already touching it. Let's say you are already touching it. So what happens? The next thing, you are touching it. So it will say you want to reverse the velocity. You reverse the velocity. What happens then? You move the ball. The velocity becomes 0, minus 10. Now you are going up. So you go little up.
Yeah.
You go little up. And what happened in the next frame?
It will be 0, minus.
So you moved little up. You moved little up because the position has changed a little bit. So the position, instead of 0, 0, the position has gone little up. But then again what happens? You will again apply the gravity.
Yeah.
And the gravity will say now you have to move back downward little bit. Right?
Yeah.
So you see what is happening. you see what is happening every time applying the gravity, and then there is a collision, so we'll change the direction and the gravity will move the object a little bit, and then because the gravity is there, we'll come down again.
Oh,
so we'll
it's going like this.
yeah, and but we are going little bit because of this small 100 millisecond or 10 millisecond.
Yeah.
So that is why we'll forever keep doing that. So how do we stop that? The only way we can stop that is
when it goes up, you could like.
No, after when we are near the boundary, we need to set the gravity to 0, so that it does not change forever, right? Those direction. Okay.
Oh, so.
Yeah, means there could be other ways, but that is the reason why it is happening, because of that gravity thing, you know.
Yeah.
Yeah. So let's try to see if we can solve this problem, you know. So this one is a tricky one. So what we do is that we have this gravity, right? And let's call it CUR, current gravity. So now instead of adding the gravity was originally a constant value, right?
Yeah.
Which never
Changed.
Now we will say the gravity is a variable. It will keep changing for the frame. Okay, so we set the gravity to whatever is the original constant gravity. Okay, original constant gravity, right?
Yeah.
But if there is a if we hit the which wall?
Which wall is the downside?
Down one is this one, right?
Yeah.
This one,
Yeah.
right? This one. So if we hit the down wall, we want the gravity to be 0. Vec 2D zero comma 0. Okay. So now we are, if we are near the gravity near the down wall, we'll set the gravity to 0. Okay. So let's
Right.
check what happens because of this. And another thing we want to kind of understand. So another thing we want to understand is that the friction, one friction you know is when we are in the air.
Yeah.
The other friction is when we hit a surface. So whenever we hit a surface, there is also a friction which will slow our ball even further. That is why when the ball bounces, depending upon the surface, sometimes it will bounce a lot back, sometimes it will not bounce that much. So there is some sort of friction in the surface also. Okay.
Yeah.
So what we want to do is, let's say our ground surface has more friction.
Yeah.
So we instead of returning the same thing full size, we want to make it 0.8. Okay. So we'll make it 0.8. So we are now losing some velocity in the y component every time we hit the surface. So let's see what happens. So it will only go 0.8 every time we hit it. Okay. So now it is going.
Yeah, but it moves.
Yeah, it will slow down. It will eventually slow down. So it's slowing down, right?
Yeah.
So it's just rolling. It is
Rolling.
rolling, and it stopped, right? So it's better. It is much better, right?
Much better.
Much better. So now it should stop.
What? Oh, now it's rolling slowly.
Yeah, but it is much better. Like it is working fine. So maybe the only thing we wanted to do now is maybe we want this drag to be little more, like same as this 0.8.
Yeah.
So now we'll have same, right? The drag and as well as this thing is the kind of same.
It's
right?
2 only.
Yeah. No, it. Okay. Yeah. So nearly we
Stopped
stopped.
it. Yeah, but it also has to happen on those sides.
Hmm?
Like on these two sides. The right one and the left one.
So yeah, the only question is that why did not it bounce at all when we, yeah, now 1 bounce, 2 bounce,
3 bounce. 4
yeah, I mean
bounce,
it's
5
fine.
bounce.
Now it is fine actually, it's fine, its behavior is good enough, right? It's
Yeah.
rolling a little bit and then it kind of stopped, right? That's how the ball will behave, right?
Yeah.
This is exactly how the ball will behave.
Bouncy ball, how
Yeah.
it behaves.
It will still roll, right? It will still roll. So yeah, means this looks fine. So we are done with this example, right? So yeah, that's done. Let's just check our, remember, other example, which was the second one, right? What was this about? This was about moon, right? So
What are we doing in this one?
I just wanted to show you what, the other thing you are discussing, right? So if let's suppose, so the moon is at the, where is the moon? The earth is at the center, right? And the this is our moon, right? Position. So let's say the position of this thing is also near the earth. So earth is where? The earth is at the, where is the position of the earth? Earth position.
No, that's the moon's position.
But what are we? Oh, so we are calculating the earth position. So the earth position is how we calculate. Oh, the earth position is here, right?
Yeah.
So the position of the moon we want to calculate. Let's say. It is half, right? So nearly at the center, right?
Yeah.
And that is half of how much? How much is the screen size? 1500 and okay. So let's just try this at. So we want to maybe to learn about this. We can go with a 0 acceleration. And where is this acceleration being used? Okay. 0. We're going with 0 acceleration and we go to 0 velocity, right? So that everything just stops, right?
Yeah.
So we just want to try with the initial to understand. Okay.
What?
So it hits the earth, right?
Yeah.
So it hit the earth. Yeah, in real world it will not go through it because we have collision detection, right? It will just collide, right, and stop there. But right now just hit it, right? So why did it hit? Because we have the yeah, it should have not let. Let's talk about. We wanted to actually maybe initially go with 0 acceleration. We'll just right now, for example, we'll just make it 0 acceleration, so that we can show that where is the vect 2D 0, 0. So now it will just not move, right? So it's here, right?
Yeah.
So let's move it here. Let's move it here. So we want to just move it here. So we'll need to move it. The x component will make it, let's say 300. Okay. Maybe 500. Okay.
600?
Maybe 600.
No, 700.
600. Okay. Now we'll move it
650.
700. Okay. So this is how you are on the earth. So now let's say this is you and you are on the earth and you make a jump. You make a jump. You make a jump. So what does the jump will look like? What will the jump look like? So this acceleration is no longer 0, 0. Okay. But what the jump look like? So let's say you do a big jump. Okay. What does the jump look like?
How does the jump look like? Like
So
you jump
jumping
in the sky and then gravity pulls you down, basically.
Yeah, so jump will be in the opposite direction of the gravity. So the acceleration which we have is the earth position minus position, right?
Yeah.
This thing, and we calculated this direction, right? Acceleration direction, right? Initially. So this direction it will go on the opposite of this direction. The jump will be opposite of this direction. So let's call it the jump. Jump is gonna be opposite of this direction. Okay. So this is gonna be into -1. Okay, but we don't want -1, we want some amount, right? So let's call it 100 minus 100. So or maybe call it 500. You are a very big jumper. You did 500 jump. Okay, so you got this jump variable. You got this
jump variable.
Yeah, jump variable. Okay, so yeah, so but we want to use the jump as one time jump. Okay, so yeah, we
And
don't.
I keep on jumping, I'll get tired.
Yeah, you get keep forever, right? You go up. So you want to kind of do it one time. So to do it one time, we need to calculate it from here, right, outside.
Yeah.
Okay. So to calculate jump, we need to do. So again, we need to calculate this first. We need to find the direction, right, of Earth and the position of the. So Earth position and the position of the yourself.
Yeah.
So you do minus, so you get the direction, right? And then you say you want to kind of find the. So this is fine. We will be able to. Yeah, we'll fine. We'll do fine with this. So this is a jump one. Okay. So we'll do the apply the jump as the velocity of. Now this we got the jump. So we'll put this jump as the velocity. So this is gonna be your velocity. So jump is your initial velocity. JUMP. Jump is your initial velocity, and then you're fine. Now you don't need to worry about jump here, and you have acceleration which is happening.
And you don't need to also burn acceleration equals Earth position minus position, right?
Yeah. Now let's run it again. What happened? We did mistake something. Oh yeah, we did mistake something.
Earth position.
Oh, we just. So Earth position minus Earth position is undefined. Oh, because the Earth position is defined afterwards. So we need to just do it like this. Okay, stop, and then we'll see. Where is the ball?
Where did my ball jump to?
Maybe just jump too many distance. Okay.
Look
So
at that, red. I'm not such a big jumper. What? These just went super fast.
So we are
What's happening?
acceleration. Okay, we'll just check. -1. Okay, if we jump a little bit, right?
Yeah.
And then we come inside, but that will never happen. But that's what happening because But you do realize that you jump and you come back. You are not circling around.
Yeah.
You are not circling around. And let's say you jump little bit more. Let's say you do 10 times now. You do 10 times. Now you'll get more higher. Oh, you got too much higher. Or maybe you do only 3 times more jump, 4 times more jump. Okay.
Wait. What? Just go down.
Maybe 2 times only. This is just going too fast. So you did a little high, but again you hit the Earth only, right?
Yeah, but Earth keeps
So you realize that now we are hitting the Earth only.
Yeah.
But if instead of doing a jump, we launch a rocket now. We launch a rocket, and it will not jump straight. It will go in some path. Okay. So we'll do a little kind of rocket kind of thing. And that's what we kind of did with rocket, right? So we made it.
Oh, and the rocket should land somewhere on the Earth.
No. So let's
have a start position at the end position.
Yeah. So now let's kind of do the rocket thingy. Okay. So the position is 300. Okay. The position is 300, and the velocity is no longer we need the jumping thing, right? And the velocity is, let's say,
rocket.
No, we just want the velocity to be going up, I guess. The up is which direction? Minus 100. Okay. Now what happens? Let's see. So you are. So what happens? The rocket put you here, and you were moving in this direction.
Wow, it's
so
going
what?
in a circle.
Now it start moving in the circle, right?
Wait, it's in a. Oh.
So again, try to understand. Try to understand little slowly. So you rocket went first here, and then the direction was set to this direction. So you kind of put a rocket which was moving like this.
Yeah.
So you keep forever moving like this.
Yes.
Okay.
But it looks more like a boot now.
Yeah. So just to give you the example. Now this is how the satellites are kind of launched. Mean like rough idea, not necessarily the exact idea. So let's just discuss this part. So we were.
You kept the pen right there, Daddy.
Okay. So we discussed this part. So we said if you are on the earth, so if you are here and if you do a jump, you'll go like this. And the direction is always opposite to the direction of gravity. So you'll come back to the earth.
Yeah.
You come back to the earth, wherever you are. You might think that it's downward, but it doesn't matter. Earth, the gravity is always going in the same direction, which is the center of the earth. So it doesn't matter where you are, you'll always come back.
Yeah,
right?
Even if you might feel like you will fall into space where you were.
Yeah, no, like if you go too far, then you'll be outside the gravity of Earth, and that's a different formula. We'll learn that later. But what the rocket did was, the rocket launches up, and then it kind of give you this speed. It kind of give you this speed. This speed. Now this speed will keep changing because of gravity. Okay.
The velocity will change.
Yeah, and then we forever keep rotating. We forever keep rotating in this direction.
But
you see?
rockets land after they're done.
No.
Wait, like.
Yeah, they will. But the rocket's main job was to give velocity to something. So the rocket job was to put something in the space. So it goes here. Rocket carries two things. The rocket is there, and the satellite is there. Okay, a satellite is also there.
Yeah.
So what it will do is it will give the satellite the speed, and then it will become removed from it will detach from the satellite. And the rocket will come back to the earth, but the satellite is forever in the sky. And the satellite is what help us do internet, our GPS, everything is because of the satellite in the space.
Wow.
So and the satellite is rotating around the earth. Okay. So that's how the satellites are launched. Because of gravity.
Oh, so it's wow, that's so cool.
So that's what we have learned, and
we'll stop the video here.